All right, let's move on to the next session. Let's welcome Alex from Blade Games to share with us tech stacks and mechanism design for autonomous world. Round of applause, please.
Testing. Okay. All right. Okay. Let's see. This is great. All right. Okay. Before we start, just quick show of hands. I'm gonna ask 3 questions. How many of the people here played games on a weekly basis? All right. How many of you guys have played on-chain games for once? Okay. How many of you guys are building on-chain games? Cool. All right, let's get into it. So basically, Blade Games is a fully on-chain game studio. We're building across the L2 stacks. So we've used quite a bit of different stuff from ZKPs to trying out fully homomorphic encryptions to OP stack rollups to some research on Dojo. So I'm going to talk about some of the stuff, how we got here, what we've learned, building these games and having a ton of players kind of flooding the RPC and what breaks or whatnot. And then I'll talk about tech stacks. And then while all of a sudden you have autonomous worlds, kind of a quick rundown of history, what happened in mid 2022 to up until now, after Dark Forest. And then lastly, I'll talk about some things that are interesting to you guys. It's kind of where do we use these technology to make interesting mechanisms. So right after ETH Denver, we talked to a few ZKP researchers, and we're thinking about making a hidden information game that's a dungeon game. So the basic idea of dungeon game is basically you take a group of units, and then you go to the dungeon. There's some creeps you can kill. There's some loot you can capture. But then at the same time, it's an asynchronous game. So where players can preempt and then just put units in the dungeon and then ambush you. And then we basically, if you go in with like 10 units at 10 fighting power, we want something that can compute, and then the other opponent have like 5 fighting power. We want something that's, you don't know that 5 fighting power. You're in the dark. And then the computation results only comes in as encrypted, and you only know, oh, the opponent probably has no less than 5 units, right? So that's something that we can do. So we asked a zero knowledge proof researcher, and then we came up with something that's using fully homomorphic encryptions. So that's basically two parties will come in and then run some computations, and you only know the results instead of the data that's participated in it. So that kind of worked, but then obviously FHE is slower, and then it has a lot of proving cost. And then putting that onto ZK EVM have pretty high gas cost. Plus something that the Dojo person described also, if you want to run like customized block time, for example, you don't want 12 seconds, you want like 2 seconds. And then you had to basically run an app chain. But then run an app chain, you need to run your own provers, which is extra cost. For early stage game studios, we don't think that's a good fit. So we move on to another game. So the second game that we built is called Loot Royale. It's fully on-chain, real-time battle royale game. It's 4 people free-for-all games. And then that's using mud.dev. You guys are probably familiar with this, or this kind of earlier version of, there were kind of early runners of fully on-chain games. So we used this, we launched about like 16 to 17 days ago. We're currently running at like 20K unique burner wallet addresses. And then about like more than 20, I think we're at 24K sessions completed. So if you want to play the game, you can just go to rolluproyale.netify.app and then just try it out. So this is basically the game build. On the top right, you can basically see there's a smart contract wallet that's there. So that's a burner wallet that's stored in your cache, browser cache. And then there's basically a timer that says time to move. That basically is 2 seconds. So per 2 seconds, the app chain that we customize produce a block. And then players will basically just move from block to block to kind of capture these loot boxes. And then you basically grow your fighting power. But then eventually you'll be basically clashing and walking to the same tile. and then a compute will happen. This happens on two levels. Either you can take block height and do a hash number, and then basically turn that into a random number from -65 to +65. Or you can use Automata VRF, which if you really used it, it kind of slows the game down a little bit because you basically have to fetching number from VRF. So the version, we can turn it on and off, but just something that like when you're building games, you can keep in mind of. And then basically everybody stakes some money and then play it, and then eventually there's only one person last standing, and then that's the end of the game. So that you can basically fork some of the backend code and then put that into a wallet, put that into a chain, or put that onto a cross-chain bridge, and then play it with their tokens. So that's kind of the magic and kind of beauty of really fully on-chain games, that you can, it's really composable, and then you can do like profit shares and stuff. So what we learned from that, so thanks to our CTO Sosumi, so we broke the RPC for a few times. So basically the game is down in the first 2 to 3 hours. It broke like 2 times because the sudden influx of traffic. So basically the third point, so basically you had to do a lot of RPC scaling. You have to basically, you need your own custom nodes as well as indexers. RPC hit rate is delicate. What does that mean? So when you send a bunch of transactions onto the blockchain, some transactions doesn't get bundled into that particular block, and then that'll basically drag your unit to the original position because every move is actually a transaction. So how do you actually make sure the RPC hit rate is kind of less laggy? Because you'll be basically seeing a lot of just attacks doesn't go through, or kind of just like movements doesn't go through. So how do you optimize your smart contracts to a place where RPC hits more often and more accurately is a big issue. And then also like when you really trying to put like smart contract wallet into the game, whoever's building it feels like it's pretty intuitive. But then actually when you actually to push this to like, let's say like 10,000 players, there's quite a bit of people don't understand the difference between a smart contract wallet that's in browser and then a plugin that's MetaMask. So when you design those, you have to be very careful with UI UX design to make sure this is like pretty intuitive. One of the way to do it is just to embed this and then have your faucet to kind of just send tokens, and then people don't even see the wallet, and then they just play with it. Our version kind of exposed the wallet front end, and then it's just everybody kind of asking, oh, how's this different from what MetaMask? Which one should we use? So that's something you can avoid. Or you can just have people just kind of click in there, but then at the same time, that just mint a 6551 token, and then people can use that as a wallet, kind of linked to their social addresses and stuff. And then lastly, definitely have if you scale beyond a certain point, then having customized indexers. If you're building just like more people, let's say just kind of like BattleBit remaster, you have 100 people playing at the same time in the same room, definitely you need to have your own indexer to pick up data. And then the second game that we're working on is basically writing code in C#, and then that's in ECS, Entity Component System Design Patterns. And then you can basically put, let's say, just creep spawns or attacks, or kind of just loots and stuff, and then prove that part of the logic with ZK-Wasm. So that game will be running on a server, but then at the same time, the gameplay part of the gameplay or entirety of the gameplay will be able to is provable on ZK-Wasm. You can also do that with Cairo on Cairo VM, which Shoshin, which some of the game built by Topology is doing right now. But then there's something that you need to also be careful with. That's something we're figuring out. We're definitely open to talk to you guys like on hash, to kind of just jam on ideas on this, which is how do you actually write those circuits? And then how does those circuits kind of reduce verification costs or even more like proof costs? Because for example, like ZK-Wasm is using Halo 2, and then the following Groth 16, the following Halo 2 doesn't have like a dedicated proof aggregation system that reduces large amount of ZKP proving costs. So that's also something when you try to grow audiences. Yeah, tech stacks. So Mud, we're short on time, so we'll just speed up a little bit. So Mud basically have a very nice on-chain database. It's SQLite. Basically, it's the when you query data, it's very the data size is quite small, and then it's easier to put into browser. A lot of the browser game you can actually make it with Mud quite easily, and then it's just better at dealing with state changes versus some of the stuff you see at like Diamond proxies and stuff. World is basically just a kernel or kind of environment for you to put access control and control versions and stuff. Indexers, bear in mind if you use Mud v1 is not, I don't think it's available to public right now, but then the Mud v1 v2 indexer is quite different. Further down the road, if you want to build like games that runs with a lot more players, you might want to write your own indexer in Go language instead of Solidity, just to accommodate much more traffic. Some of the useful links if you want to take a picture, or you can DM us on Twitter. I'll just send the Dex link. Emojimon, basically you want to play out with the basic tutorial. If anybody have played with FrintTech and stuff, progressive web app that basically skips the entirety of App Store and stuff. So there's like already made libraries out there. Mud tokens, definitely remember to write a withdrawal function from world contract. So that like even if you issue token, you want to take it out or you want to put it on the DEX, the tokens runs on the world contracts, and definitely write a withdraw function. There's some interesting like design challenges for Skystripe, which is the kind of just like a flagship game for mud.dev that people are running different kind of plugins. Frenzy plugin is basically in a 3x3 square, your units attacks any 3x3 range units automatically and then returns to the same position. And then there's Unity Godot integration with Mud coming out. Dojo, I'll save us some time because it gets talked quite a bit in the previous session. And then there's Keystone, Argus, and Paima. They have different features. Keystone's basically running for gas optimization purposes. They have precompiles. A precompile is basically turning a lot of the bytecodes, let's say like 0x, ABCDEFG, 1, 2, 3, 4 into 0x2. And then that saves a lot of gas and kind of block spaces. And then also they use Go language to rewrote the entire OP stack rollup framework. So just to play more, be able to develop more kind of RTS or MMORPG games. They have a pretty cool RTS game coming up next year. So definitely check them out. Argus is more kind of just Kubernetes for game engines. You write configs, and then they provide quite a bit of technical help, and then you can basically deploy with any of the current existing on-chain game engines. And then they have some game shards that just scales the game much better because the state changes are managed in their respective shards. And then they have some customized sequencer, which gets talked about quite a bit. You want to customize the pace of the game. They have some games in the pipeline. You want to watch their video. I think happened in October. You can check out the video there. Paima, there's a few games that is live already. The good thing is you can basically write JavaScript with it. So definitely try it out. So what are some of the rollup frameworks that you'll be working with if you're not building on Optimism or you just want to have more freedom over how the game is paced? So you can do Altlayer. It's pretty good for games that doesn't have a big room, and then you have like 400 people playing in the same room, and you want to manage those state changes all at the same time. So if you're running, let's say, like a Reddit or like a WhatsApp channels, they'd be basically spinning up like 20 rollups and then manage room 1 to 20 and then 21 to 40 per rollup, and then they roll those states back to their beacon layer. So you can scale your game horizontally across different rollups. And then if, let's say, Saturday, Sunday, today, quite a bit of people are playing, you can basically ask them to scale up like 40 rollups for you. And then weekdays, maybe not that many people playing, you can ask them to drive it down to like 5 and stuff. So pretty neat rollup frameworks there. We're working with them. Caldera, there's a pretty famous game, Primordium, that's out there. And they're offering a lot more kind of customization across the OP stack framework. Definitely check them out. And then there's Conduit. I think Asian8 announced some partnerships with them during Token 2049, so there's something you can check it out as well. ZK there's something that I think that's quite interesting. It's just like if you use these kind of OP stack kind of tech stacks, it's great for turn-based games. But if you want to run like tower defense games or like shooting games or any type of like really real-time games, you probably want to put some of the game's logic on the server, and then it's easier to run, and then you use zero knowledge proof to prove it. So use Rust, use Bevy engine, and then use RISC-0. Or you want to use ZK just use C++ or C. Or lastly, there's a very interesting new project that that's coming out. That's after you use these and you have like 5,000 players playing, you use Nebra1 to drive down the proving cost. If you're, let's say, generating like 200K proofs, 200K proofs a month, you probably will need Nebra1. They'll go live on Cephalia testnet next month. Messaging protocols, Web3MQ, Sending Labs, just check those out. Pretty good messaging tools. Why all of a sudden you have autonomous worlds? Well, right after Dark Forest was created in 2020, there were just a small group of builders on Gnosis chain on Ethereum were building games. But then 0xPark announced autonomous world residency in 2022. They demoed a game, I think 1 or 2 games in last year's DevCon Bogota, and then they have a secret SkyStripe tournament hosted. And then that's kind of where the initial core of people, and then Curio and Argus was also building out around that time. And then they gathered together and put together a book called the Autonomous World Book. You can check out some of the stuff on aw.network, but then they just like spread kind of the book around and then just make it kind of like a mafia kind of thing. And then a Moving Castle was kind of the project team that put the book together. If you want to read out the book, I think there's copies that's out there. That's on the internet. You can just search for it. It's out there. There's some pretty interesting pieces. I think Strongest Crypto Gaming Thesis by Gupsheep. That's quite nice. There's also like Ludens from Mud that wrote a case for autonomous world. Timekeeping for digital gauze is very interesting. You should check it out. They're basically describing kind of building virtual physics and like kind of just laws of a virtual world running fully on blockchain. And then in May, there's On-Chain Game Summit, and then there's like ETH Global Autonomous World Hackathon. And then now all of a sudden you have people that are building on Starknet, people building on like Optimism, and then like on Solana and different kind of builders that's out there. It's kind of, you have a sudden influx of new builders that's out there. And then also definitely make sure that you check out Lootverse. That means basically loot bag, realms, Crimson Caverns, as well as some of the stuff that's out there. Why is it important? Some of the games on autonomous worlds that you're using have to have stories. So stories can range from a newspaper, article, a novel, or kind of characters, spell books, skill trees, and all that stuff. So you can find those fully on chain out of the metadata that's stored on realms, let's say a map, or like weapons on, let's say, on loot bag. So definitely try it out. Some of the stuff I put there, basically from low fidelity, is just a few words. You can basically use stability XL, Stable Diffusion to just turn this into high fidelity characters, and then just ask the community around you or your friends to kind of just run these content contests, which I think is quite interesting, especially when you're like bootstrapping early communities of any games. So just having these like shared stories and then having these like rooms for imagination is quite important. Mechanism design. So this is something that we've recently talked about with a friend called Gink. So you can follow him on Twitter. So ERC 6551 basically decouples your account from approval functions. And then what you can do is basically run these little arcades. Then you can basically program a little arcade, let's say just like a ping pong game, or let's say like a tank game. And then you say, hey, if this player pays 0.01 ETH and then play the game, if they finish the game, I store like 10 USDC within the ERC 6551 token. If they finished it, then they can take the money. Otherwise, they have to pay like 1 USDC to participate in the game. So that way, you can basically have a ton of different little arcades that's running fully on chain. You can test this with a group of friends of yours, and then just like use it as an interesting contest with them. So that's async battle. Like, what does sync battle means? So you'll be basically, you can also program characters. So like Shoshin have this code that basically program your characters and say, like, in condition A, your character does this. Condition B, your program does this. And then you have another player that's also condition A does this, condition B does this. And then basically you can have a sync battle between two kind of on-chain entities. And then both of them holds like 100 USDC, and whoever wins takes the other person's 100 USDC. So that's very, very interesting design space. You can basically use AIs to fight against each other and then just speculate on them. And then there's one last thing called like player-owned NPC. Basically, you just do these like miniature dexes, decentralized exchanges, and then say, oh, I have these much resources. If you give me this, I'll give you that. So that's very interesting design patterns there. ZK Hunt, it just came out, I think, 2 days ago. We're running a little short on time. You can take a picture on this, but very, very interesting. So remember, like at the beginning, we talked about FHE and just hidden information game. They have a challenge response system that deals with hidden information. And then if you propose this challenge and then search, after X amount of time, if the player doesn't respond, you can slash them on chain. And then because these messages are only visible to that particular addresses, the rest of the players cannot see them. So there's quite a bit of excitement or fear you can put in players' heart to kind of just using these hidden information techniques. There's more stuff that's written by tonk.gg, commit reveal schemes, multi-party computation. I'll just not talk about too much on this. And then real-time games, like if you really, really just want to run like World of Warcraft, a fork on World of Warcraft on a blockchain, check out using, remember, like it's not there, it's not being talked about for quite some time, but state channel still works quite nicely, because if you're just running for like 5 people or 7 people and then they're kind of just farming a boss, they can just basically run state channels and then communicate state changes. And then after you close that session, like you leave that particular room, the kind of state changes are summarized and push it back. You push the CKP to the DA layer or to the rollup layer, and then just that concludes that. There's also very interesting, like Ryan Burmack's, like Berkman's basically running these like CKP machines, and then if you have more people running the machines, you have more ticks, and then people are rewarded based on the number of proofs that you prove. It's also very, very interesting. And then the games kind of just gradually slows down over time, and then the game kind of just concludes on a certain time. And then that's pretty much it. That's a speed run. So if you have any questions, be happy to answer that. Or if you want to talk about game design and stuff.
Any question from the floor? We have about 5 minutes, so maybe 2 or 3 questions. Show of hands.
Cool.
All right. Well, then, thank you, Alex. Oh, yes.
Yeah, sorry. So the AW space is growing very fast, and then there's certainly opportunities in here. You can see we partner with a lot of the ZK teams and AW teams. So now we're growing a little slightly faster, so we just need like a front end guy. So yeah, if you're interested, yeah, we're hiring. Yeah.
Whoever that's interested, please, there's a chance here. Reach out. It's your opportunity. All right. Okay. Thank you. Thank you, Alex.